do number 4. Quickly go through it. So for A, we do AI. It says we have 2 mechanisms here. Which mechanisms involves the use of a catalyst? So we know that a catalyst is going to appear as a reactant and then as a product. Okay, so it's there at the start and there at the end to show you that it wasn't part of the reaction. So we look for something at the start. O3, is it there at the end? No. Cl, is it there at the end? Yes. So Cl is a catalyst. So which mechanism? I can say mechanism 1. Mechanism 1. And name the catalyst Cl gas. Okay, chlorine gas. Like this. And then part 2 would say identify the intermediate for each mechanism. Well, intermediate is product first. It's made and then used up. So it does not appear the product. So it's going to be here, this ClO guy. So for mechanism 1 is going to be ClO gas. Then mechanism 2, so here we have the mechanism 2. We want to see who is going to be, who is produced and then used up. I can see O is produced and then O is used up here. So it says it's going to be O. All right. Now, what about part 3? Write down the overall reaction for each mechanism. Okay, so for mechanism 1, let's put the overall reaction. So what I'm going to do on mechanism 1, I'll cancel out things that are appearing on both sides, even if it's in equation 1 and equation 2. Okay, here I can see Cl is appearing on the left and on the right, so it goes. TClO on the left and on the right, so it goes. Is there anything else? No, there's nothing. So in here, what would we have? We would have O3 gas plus what else? O, this O gas, okay, plus O gas. And here, what happens is you'd have it making O2 gas. So in here, what do we have on the other side? O2 gas. But there are 2 of them, so it'll be 2O2 because it's this one and that one. Right? And then for mechanism 2, so here, let's have it. Our mechanism number 2. Sorry for the end writing. Overall reaction, let's cancel things that are appearing on both sides. On the left, there is O3. Anything? No. On the left, there is O3 again and O. So what we are going to have is we are going to have O and O cancel, okay? And then O3s are on the same side and O2s are on the same side. So in the end, you're going to have 2O3 gas going to be, here is going to be O2 plus 2O2, which makes it 3O2. Okay? So that's going to be mechanism number. It's going to be 2O3, okay, gas, right? And then it's going to make 3O2, okay? So it will be 3O2. Now that's what happens, isn't it? So we just write it as 3, then O, then 2, okay, 3 moles. All right, now, is there anything else? Write down the overall reaction. We've wrote it down. And then part IV says, sketch a well-labeled diagram, energy profile diagram for the catalyzed reaction. So catalyzed reaction. So here we say that they say the decomposition is an exothermic. So exo means it loses heat like this, okay? All right. So in here, what we are going to have is it goes like this. Because it's an exothermic, it loses energy, right? And in here, we are going to have our delta H, okay, between these two. And then this is where, So this is delta H, and in here, this is going to be the EA forward. So yes, that's it. All right. So you forgive me for being a bit sleepy. Okay, so yes, when we put our energy enthalpy, so this is going to be obviously the reverse one because we're coming from products back to the mountain. So here, this is going to be our EA forward. And then what else do we need to put? Okay, you can put the things. So you're doing for the decomposition of ozone, right? So yeah, you can put the overall reaction, you can put the products, and you can put the reactants and the products if you want. Okay? The decomposition, three marks, but basically you've put your things. Don't forget to put the units. Here is going to be energy, then here it is going to be progress of reaction. Okay, and that's done. So here is our progress of the reaction. That is what we have, and we'll be done with this one.